lights are staying on here and the internet's working right now. So I hope we can get this done and make it some meaningful review for those of you that have the test coming up, which is all of you. Nobody took it Tuesday. So I got several people down for this evening and some for Friday morning. And a couple need to fit into one of those categories, and you need to let me know on that. But some of this that I wanted to talk about today. So I hope you all can drop in and join us. It's getting close to 10 o'clock now. And we'll see what we find. I'm going to get this onto the piece of paper here. I have a few of the things that I was looking at on this test that I want to get back to. So we'll get back to this. Be able to follow along.
Well, give them what's left and then make another.
I want you to look back at the old homework. You got homework that you're working on. It's the second part of chapter 5. I want questions on that, but I also want you to spend some time looking at the homework from 5.1 to 5.3 because that's part of this test. Also, the ideas about inverse functions and domain and range and composition and stuff like that are concentrated on in there, and that's all part of this test also. So you want to look at those, see if any questions come up from what we did back then. I think it went pretty well. It was a long time ago now. So look at that and see what you think. Let's see what we can do here. I'm going to try to get this onto the piece of paper effectively so we got something we can follow along. Yeah, these are ideas that I wanted to look at a little further. So I mentioned the earlier homework there. If you've got that to look back at, I believe that was all returned. But if you want to look at 5.1, 5.2, 5.3, look at the questions and ideas that were going around back then because you need some review there. That was a long time ago. Try out some stuff from their composition as part of that. We want to see how those work. I want to talk a little more about domain and range as it comes to functions. Functions, specifically exponentials and logarithms, which we're working with now. But I want to start with today with regular algebraic function, kind of old-fashioned algebraic function to look at. So I got a question here to address all the homework on Zybooks. Now, know that I'm still going to collect like paper homework from the textbook. It's just that instead of handing it to me in class, you're going to be emailing that now. So there is still a homework list on the Blackboard site. I had a link to it, I think, in the weekly announcement. But that means there's problems from do just regular written problems. Yeah, just send me pictures of these things. So you're going to either scan or take pictures of the pages on your work on that and send it to me. I made the next one due next Monday, but that's what you ought to be looking at now in preparation for the test, making sure those get done. So on that homework list, you should see stuff from these sections that's due Monday. That's in your announcements there, someone. Okay, focus doesn't look like it's coming through real great on this. Seeing what I can do. Okay. Somewhat readable. Function like this, you have, think about the domain and range of this thing. And we'll think about the inverse of it. Let me write this down right quick. This is regular x squared function, except the plus 7 shifts it up 7 places. So thinking about the graph is a good way to get a sense of domain and range. But this is just going to look like this. 7 places up is where it starts. It goes up. So your domain is actually all real numbers. All of the x's can be done. Interval form, that would be from minus infinity to infinity. The range is the interesting one that you're only going to end up with values from 7 to infinity. So old-fashioned list of things that you look for domain restrictions was, that the inside of a square root has to be greater than or equal to 0, and the denominator can't be equal to 0. Those are the two things that you can't do with real numbers. You can't do the square root of a negative, and you can't divide by 0. Well, there's a major third one added to that list. Now, you also can't do the log of a negative. Any logarithm of a negative is not a real number. So logs have the restricted domain also. That's going to be the big addition to that list for the chapter that we're on now. But I want to think about inverse functions of something like that, how to find the inverse function, and then think about what the domain and range do there. And then we'll do the same thing with a exponential function for comparison here. So to find the inverse function, we had that switch x and y and solve for the y in there. So this function can be thought of as y equals x squared plus 7, where that's your input. X is your input and y is your output. If you switch that around to the inverse, the relation would be that x equals y squared plus 7. And you can solve for y in this thing. Well, sort of. Okay. That does not have a regular inverse because of that plus or minus that shows up in it. This is not a function anyway. This is the inverse, and it's not a function because of the plus or minus. You could see that this was not a one-to-one function, and that's why the inverse didn't come out right. Looking back at the original function, fails that horizontal line test, right? We get the same output here, and here we get 9 at 2 different places, or 10 at 2 different places, and so on. You're not going to have a inverse function of that because it's not one-to-one. If we restrict this thing now, I'm going to cut off the left side of it and just start from right here. So now I'm taking the same function, but I'm restricting the domain to 0 to infinity. Only do the positive half of this. That's going to have a nice inverse now, because if we only take the positive x's, that means in the inverse, we only take the positive y's. So I know it is the positive square root of x minus 7. And there we go. We have an inverse function now. The inverse function would be the square root of x minus 7. And we took care of that other problem by restricting the domain down. But observation about the domain and range of this thing now. That's your square root function. Looks like this. Shifted over 7 places. The domain is from 7 to infinity. And the range is from 0 to infinity on the y. So if I can get those both on the screen at the same time here slightly, move this. You can see this comparison. The range of the inverse is the domain of the original. And the domain of the inverse is the range of the original. Domain and range kind of switch places when you go to the inverse function. That's what happens when you are changing input and output, right? This was all about switching the input and output. So the domain, which has to do with your input, switches places with the range, which has to do with the output, and vice versa. So that's how the inverse functions would work. I'm going to look at an exponential example for that. Review this idea, but also review kind of how the exponentials look and the change to logs. Fresh page for that. All right, so similar situation, original function given, we're going to find the inverse function, and we're going to find the domain and range, both of these things for comparison. So an exponential function might look like something like 3 to the x minus 2 plus 5. I built in a couple transformations there so we can think about how that works. Your equation of the function is y equals 3 to the x minus 2 plus 5. So the base function of an exponential base 3 to the x would go through 0, 1, and 1, 3. And have this shape to it. We're going to shift that. That's going to be 2 places to the right, and that's going to be 5 places up. So my transformed function is going to look like this. 2 places to the right, it would be a 2, 1, and 3, 3. And then I'm going to go 5 places up from that. So I'm moving this over 2, and then I'm going to move up 5. So 3, 8, 2, 6. That's kind of what I'm looking at now. That's your exponential shape. Now it's going to level off. My asymptote here, which used to be at 0, is now shifted up 5. So it looks like that. So getting a sense of the domain, then I can think pretty easily about domain and range. Domain for an exponential is going to be from minus infinity to infinity, because x can be anything in this kind of expression. There's no problem there. The range shifted up now. The range is from 5 to infinity. Easier to see off from the graph, but that comes from your vertical shift on it. Finding the inverse on that, we can still switch letters and solve for y. The process of solving for y is where it gets. And the x is the input into the inverse function. Solve for y in this thing. I want to do what it takes to get this y by itself. So that's going to look like, I could get rid of this 5 first. And then this whole thing is up here in the exponent. There's no nice way to get this by itself except change into logarithm form. So now I'm going to rewrite this thing in log form. This is exponential base 3, input and output. Switch it over to log form. So this is my inverse function, is this thing. It's a logarithm, and it's got that 5 places and a vertical shift 2 places, right? The input and output switch places here. And but the thing we want to review logarithm graphs, your basic logarithm function. And we'll do these transformations on that. So a little space here, I can get this in. Basic log 3 of x has a graph that looks like this. They go through 1, 0, and 3, 1. Log base 3 of 3 is 1. And your vertical asymptote is here at 0. We're going to move that 5 places to the right and 2 places up. That's the shifts that are going onto the graph. So you would end up with a graph that has an asymptote over here at 5. This kind of shape it goes through. Those points would move over. I'm just doing the horizontal shift first. This is over to 6, 0, 8, 1. And then if I shift that up 2 places, my new function, this function would be up here 2 places up from there. 6, 2, 8, 3. I'm getting small here, but this asymptote would still be here, but the curve would be moved up 2 places. That's this function. And so the domain now is to infinity. And the range, well, it goes on down forever and it goes on up forever. It's kind of slowly, but it keeps going up. So the range is from minus infinity to infinity. We can see that those have switched places from what we had on the original function. Can't really see it all on the screen at the same time, but 5 comma infinity was the range of the exponential function that we started with, and the minus infinity to infinity was the domain. We don't necessarily need the picture if you just want to think about what the domain is on this. The new rule for domain, or for real numbers, you can't take the log of a negative. So the new thing to think about with domain is that whatever you're taking the log of has to be greater than or equal to 0. So of course you could get your domain by saying whatever's inside for x minus 5 has to be greater than or equal to 0. So x is greater than or equal to 5. That's from 5 to infinity. That's good. It shows up when we're solving equations. We have to make sure that what you get for the solution to an equation actually does make these things positive, is actually within the domain. Sometimes we have to throw away what looks like a solution to an equation if, when you go to plug it in to the logarithm, it ends up with the log of a negative. I'm not dealing with those. So you got to check your answers when you're solving equations that have logarithms involved to make sure that the answers really work back in the original equation. So a little more manipulation of these things. It would be good to take some time to think about. I hope people can benefit from watching through this. There's a couple people with us now. You'll be able to check it out before you get to the test. I want to try to do some of this manipulation of logarithms to sort of put together and take apart rules. I want to get used to that. Again, because you need that for solving equations. So they usually say something like this in the instructions: write as a single logarithm. And we'll start with our big long form of something. I'm not taking this one out of the book. I'm just going to make one up here. But so I write down an illustration right here. It's 2 log of x minus 3 log of y plus 1/2 log of 6. We have to make that into just one great big log of something using the properties right here. So the properties tell us what subtraction of logs and addition of logs is going to turn into. But the properties, I'm not ready to do that yet because I got these numbers on the outside first. I got to deal with that first. So my first step in rewriting this would be to take care of these numbers out here. A multiple of the logarithm property says that can be written as an exponent. That's the same thing as log of